In this example, we are going to be doing definite integral using properties. That means we will not be using any of the integration formula. So the properties that I'm talking about will go back to page 1, the interpretation, and also page 2. So in example 6, I'll be doing integration using the property. So there won't be any formulas you can apply, because if you look at the information that they gave you, so for example, in this example, they gave you that this is equal to this and is equal to 12. So there is the fx is an unknown function. Because it's an unknown function, there is no way you can use any formula to integrate. So you need to understand what is the interpretation of the value 12. So as mentioned on the first page, that will be area under graph. So I'm going to show you a idea. So for this information, so there is a fx. Draw anything you like for your fx. It doesn't matter. Okay, then what do we mean by 12? So this has a value of 12. So the area from x equal to 3 and x equal to 0. So the area of x equal to 3 and x equal to 0. So x equal to 0 is here. X equal to 3 is here. The area here is 12. So that's the interpretation. Okay, then the next interpretation, when x is 8, from 3 to 8. So 8 maybe somewhere here. The area here is also 12. So you need to interpret it in this way. There's no way you can be using any formulas, because you don't even know the function. So you got to interpret it as area under graph. Okay, so with this, right? So if you interpret it in this way, so what is the full area from x equal to 0 to x equal to 8? So that means, right, it will be the addition of these two areas. So that means I'm adding up the two pieces. So from x equal to 8 to x equal to 0 to x equal to 8, it's like you are adding separate piece of area. So you will get a 12 plus 12. Okay, and then if you still remember, okay, let's go to the second part. So now the second part, we got two pieces of area adding up. Okay, so there's two pieces of area that you will need to add up. So for the first piece of area, that is already a 12. But for the second piece, okay, do you remember that the big number has to be on top? So I need to change the position. So one of the property that I mentioned on page 2, if you need to switch the number on the integration sign, you switch it with a negative. So because now you switch it with a negative, this piece is an area 12. So it actually becomes a 0. So when you need to use property, you need to see it as area, pieces of area. Okay, so sometimes it can be asked in this way as well. I think this one I forgot to type a dx. So right now you're supposed to integrate 8(3), okay, fx minus mx equal to 0. So if you still recall on page 2, one of the property is we can split the definite integral. So I can split into subtraction. So two individual definite integral. And then this whole part is a 12. And in fact, you can bring the definite integral over. So from a negative definite integral, it becomes a positive. So from here, you do your normal integration. So it's a bit like working backwards. So the definite integral is a value 12. So we need to perform our definite integral. So integrate first and do a top minus bottom. So I'm going to do it for this part. Okay, so how do you integrate mx? So if you integrate mx, it will be mx squared over 2. And then you do a top minus bottom. So go back to your procedure of a definite integral. Integrate and do a top minus bottom. Okay, then when you do the top minus bottom, do it very carefully. It's like algebra now. So when you do a top minus bottom, so you will get oh 20. Okay, so this is 32m, and this is 9 over 2m. So you will get 27.5 m equal to 12. So your m will be 12 divided by 27.5. Okay, so sometimes they will ask you to find this kind of thing. So where you need to split the definite integral into two parts according to the property. So everything will go back to the property on the second page, and the basic idea that you see as integration as under graph. So there's no longer any formulas you can use because the function is always an unknown. Okay, so maybe you need to read back the basic properties, then we can try this idea.